Hello everyone, my name is Abdul and I am the moderator from the Spectra and I will be available through this session. So, our speaker for the day is Nimanja. Nimanja is a fresh Microsoft Azure MPV and ambition-driven cross-platform DevOps professional with a high degree in many technologies area and engineering solution you didn't find on Google. So welcomed as a speaker at numerous IT conferences, sharing creative thoughts inspired by the technology. He saved companies thousands of human hours by deploying reliable code in a mission-critical workload. So, Nemanja has delivered technical training as the MCT to companies and individuals for half a decade. So currently, he works for Stack as a chapter lead, guiding a group of DevOps consultants and advising clients mainly from the fintech industry. And on the behalf of Spectra, we welcome Nimanja. We also welcome all the participants present for today's AZ104 cram session. Please pay attention to the messages that will be posted in the chat box during the session. These messages will be related to the Microsoft examination. Hope you have a wonderful learning ahead. Over to you, Nemanja.
Thank you, Abdul, for the introduction. So, hello everyone. I see that we have quite some participants today at the CRAM session, and I'm pleased to welcome you. So today we'll be going over the AZ104 content to make you ready for your certification exam. So what you can expect, this session has quite some modules, so it's going to take about 3 to 4 hours to wrap the session. Between the modules, we're going to be making some micro breaks, so you can take a coffee or a tea, or perhaps have a toilet break. I'll be your instructor for today, so whatever is not clear or you have any questions related to the certification, you can drop them in the chat. So I'll be stopping every now and then to have a check at your messages, or perhaps I'll be answering them during the micro breaks. At the end of the session, we'll be enabling your microphones so we can actually have a chat. So then you can also personally ask me any questions if you like so. And at the end of the session, I'll be sharing also my LinkedIn handle, so perhaps we can connect for the further notices, and you should be able to see my screen now. So, you know, today we'll be going through quite some material, and we're just going to do a short introduction about the content that we present, and then we're going to be diving into the module content. So the CLX program is here to enable you to ace your certification with the industry help. So we assess your knowledge and we provide the bullets that we think that you should be preparing a bit more in order to ace your certification. And for the CRAM session itself, all the content which is being delivered, also including this one today, is given by the Microsoft certified trainers and Microsoft most valuable professionals. My name is Nemanja Jovic. People call me Neo or Neo, however you like. I'm both Microsoft Azure MVP and MCT. I teach for approximately 5 years now already, and I work as an independent consultant. When it comes to the prerequisites that you will be needing for today's CRAM session, it is obviously nice to have some understanding of the technologies we'll be covering, so meaning that you have some already experience in the IT sphere. So some of the prerequisites is to have the experience with the virtualization technologies, also networking, obviously, OSI model, TCP/IP stack, DNS, and virtual private networks. And further, it's good to have the understanding of Active Directory, so both Windows Server, Active Directory, or Azure AD. And obviously, since we'll be taking care of the infrastructure from the administrative perspective, it is good to be aware of the high availability, disaster recovery, and backup and restore operations. So what's going to be your role once you get the job as cloud admin? Well, you'll be managing mostly the full life cycle of the infrastructure that is hosted in Azure. So that spans storage, networking, compute capabilities, provisioning new users, taking care of the infrastructure in terms of the scaling. You should be also proficient with Azure Portal and the PowerShell, perhaps also with AZ-CLI. And about the certification itself, back in the days, the AZ900 was the hard prerequisite. So it meant that you need to take the fundamental certification, but today Microsoft is allowing people to take AZ104 without getting the AZ900. Once you pass the Azure Administrator exam, you might be opting for going for some expert level certifications such as the Azure Solutions Architect. So we are preparing also to give much more sessions perhaps in the upcoming period, so stay tuned for our CLX program. When it comes to the study areas, they might be the subject of the change, but you shouldn't be afraid because what Microsoft is doing, for example, here you see on the left 5 study areas. Microsoft is either in the same exam, either combining the study areas to merge them to make it easier for people to study, or if there are study areas that are being added to the certification exam, usually the exam code changes them. So today we'll be going through quite some modules, and I encourage you to also reach out to additional resources when studying. So the resources that are available to you are, for example, Microsoft Learn, Microsoft Azure blog, documentation, and the forum, and obviously reach out to industry experts if you need help. So we'll be starting now with the CRAM session by going through the first module. So first module is about administering the identity in Microsoft Azure. And there we'll be covering the configuration of the Azure Active Directory, also called Azure AD, and configuration of user and group accounts. So first, what is Azure AD? Well, Azure AD is the backbone service which is taking care of the all authentication and authorization requests in Microsoft Azure, and also providing single sign-on capabilities. So basically, when you sign in into the Azure, Azure AD is the service which is handling your signing request. It also provides the access to the applications with your user account, which are either hosted in the cloud or maybe at your on-premises. So it does support the hybrid workload integration. Next to that, it also provides the device management. So next to the users and groups, you'll be able to manage the devices. Now let's have a look at some concepts that are closely related to the Azure AD. And I usually like to start from the Azure AD tenant. So Azure AD tenant is basically getting provision when you sign up for your first Microsoft subscription, and it represents a dedicated trusted instance of your Azure AD basically for your organization. It's fully isolated, and all your users that are planning to join your organization will need to have the account in your Azure AD tenant. Next to Azure AD tenant, there is Azure subscription. So if you're planning to use any service besides Azure AD, such as, for example, virtual machines or the storage accounts, you need to place them in the subscription. So subscription is used basically to pay for your Azure cloud services. Then we have some other basic concepts, such as the identity and the accounts. Those are basically the objects that can be authenticated and have some data associated with it. And basically the Azure AD account is just that, the account that you provision through Azure AD or another Microsoft Cloud service, such as the Office 365. It's good to know that Office 365 also uses the Azure AD for storing the Microsoft 365 accounts. So now for the people that are acquainted with Active Directory domain services, let's make the comparison between ADDS and Azure AD. So Azure AD is not like ADDS because it has completely flat structure. So you cannot create organizational units or place the group policies. You can just add users, groups, and the devices in a flat structure, and they can be managed by you and obviously used to authenticate. Azure AD is identity solution, and because it's web-based, it works over the layer 7. So when I say layer 7, I mean HTTP protocol. And if you compare it again with ADDS, ADDS is queried using the LDAP protocol. That's not possible in Azure AD. You would be using REST API, on the other hand, to query Azure AD. And because it's HTTP based, it uses protocols such as the SAML, VS Federation, and OpenID for the authentication, while in ADDS we have the Kerberos. Also, it does include federation services that you can use, for example, as Google, Facebook, and many more. So once you sign up for the Azure and you receive your Azure AD tenant, you're going to be getting the free version by default. If your organization is serious about the security, then obviously you'll be willing to implement some more robust and advanced features. So for that, you'll be needing the premium licenses. Premium licenses are giving you access to additional features in Azure AD, such as the conditional access, identity protection, and the governance. So it's good to know that you can obtain different licenses to gain access to different features. Now, I mentioned that Azure AD helps you also manage your devices. Now it's a big question mark behind this, because it always starts with your organizational strategy. First, your company, in most cases, when you start working for someone, there is already predefined organizational structure. Besides, if you start your own company and then you have a greenfield project. But the companies already do have some structure. So when I say structure, in these terms, it means like what kind of devices do we support in our organization? Are those just Windows devices, or we have a mixture of Windows and Apple? Then it comes to the mobile devices. This is the Android, iOS, and so on. So depending on this strategy, you can, in a different ways, manage your devices. You can either register your devices, join them, or hybridly join them. This also depends on if you have the hybrid setup with your Windows server at your own premises. So these three strategies of managing devices are different in sense of what kind of operating systems you can manage, what tools you can use to manage your devices, and obviously for what kind of strategy these ways are intended to. So what I advise is, before making the decision of how you want to manage your devices, first make sure to assess your current state of the company, and then you'll be making decision of how you want to manage your devices and what's the most suitable way for you. So at the point when you're going into this direction, I always say consult the documentation, because there might be also different ways of how you might be managing your devices at that point in time. For your certification exam, it's important to know that these are three different strategies of managing your devices, and they support different operating systems and also give you access to different tooling for managing your devices. Now, the self-service password reset. This is one of the premium features of the Azure AD, and it helps out basically offloading the traditional IT burden from the administrators. So back in the days when your user forgets the password, you usually get a call or a service ticket saying, okay, this user needs a password reset. In Azure, you can implement self-service password reset. It's a service that administrators can configure for the users to be able to reset the password on their own. And how it works is that administrators are gonna select the methods that are available to users to reset the password, such as the email, mobile phone, and the security questions or something more. And they're gonna define how many of these user needs to use when resetting the password. So then user is gonna sign up for SSPR, and it will need to provide these methods such as the email, mobile phone, and the rest to make sure to verify them. And the next time user forgets the password, you'll be able to navigate to SSPR portal and reset the password on its own. Next up, we'll be discussing the configuration of user and group accounts in Azure AD. So in Azure AD, if you want to sign in, basically you need to have the account. So your account is going to be used for authentication and the authorization, and each user account can have additional properties such as the city where the user lives, the department where it works, who's the manager, and so on. So you can either create the user accounts in Azure AD, and they're going to use your company domain to sign in Azure. Or you can also invite the user from the external organization, meaning that then user is going to be using his own company-owned user name and the domain to sign in into your Azure AD. To manage the users, you need to have either global admin role or user administrator role. And at your disposal, there are sign-in and audit logs information available, so you can check as the admin who signed in, who did what in Azure AD, and so on. In case you delete the user, you can restore all the users for up to 30 days. You also have the option to perform the bulk operations, meaning that you can either bulk invite, bulk delete, or bulk create your accounts. So when creating or inviting, you can do that by creating the CSV file, so comma separated value file, predefining the properties and the information about your users. And then instead of creating user one by one, you can do this in an automated manner. So next to users in Azure AD, we can create also groups. And groups are very important, and they let you structure your company in a better way to be more organized. There are two group types. First, there is a security group. Security groups are obviously used to grant access to some resources, such as the subscription resource group, or potentially just a single resource. And there are also Microsoft 365 groups. These are different groups. They're used, for example, for email distribution. Now, for groups, there are different assignment types. So you can either join the users manually by assigning them to group, or you can have dynamic assignment. Dynamic assignment is a very cool feature. So how it works is that you can write a query that is querying the user objects for specific properties. So for example, you have the group which is called Europe users, and that group can have a dynamic query querying all the users in your AD for the region matching the Europe. So if you tomorrow add a new user to your Azure AD and you set his property of the region to the Europe, the dynamic query is gonna find that user, determine it's not part of the group, and it's gonna join the user in the group on the behalf. So meaning it offloads basically the administrative efforts. To use the Azure AD functionalities, as we mentioned, you need licensing, and you can assign the licenses either to individual users, or you can assign licenses also to the groups. So this is going to give you the ability to basically provision the features for your users also at scale if you assign the licenses to the groups. You can obviously do this via the Azure portal or some other administrative tool such as the PowerShell. Another very interesting part of Azure AD are administrative units. Imagine that you have a really big corporation which is present in many countries, and you have different people who are in charge of different regions. So, for example, in USA, maybe you have East US, and you would like to grant access to the admins that are in the East US region to be able to manage your users that are in East US. So administrative units help you divide your company into these units. So into the users that are present in certain regions, and then also grant access to your admins to be able to manage only that certain aspect of your company. So in this case, your admins would be able to manage only the users and the devices, for example, only in the East US. So that's what you can achieve with the administrative units. All right, this actually brings us to the end of the first module. Let's make a micro break of 10 minutes for a toilet or a coffee, and then we're going to be back to continue with our material. So in case you have any questions, you can drop them in the chat, and I'll be seeing you all in 10 minutes. So have a nice break. Hello everyone, welcome back. Hope you had a nice break. It's time for us to continue with the content for our crime session. So I'll be sharing screen with you. The next module that we'll be explaining is about the administration of the governance and the compliance. And within we'll be seeing how you can configure your subscriptions, Azure policy, and the role-based access control, known also as the RBAC. So let's start with the subscriptions. So first of all, it's good to remind yourselves what are the Azure regions. So Azure is a big cloud platform present in quite some countries, 140 written in this slide, but I expect that it grew over the time, and it spans over 60 plus regions. So region is basically the collection of the data centers. One region can then have multiple availability zones within. Availability zone represents isolated data centers from the other availability zone in the region. And if your workload is replicated across multiple availability regions, if one of them fails, the other one is going to continue with providing the service of your infrastructure. What's important to understand is that different regions provide different data residency. So if you want to comply with the laws in Europe, you should be placing your workloads in one of the European regions. Also, you want to place your workloads in the region as close as possible to your users. So if you're operating in USA, you're not going to deploy something in Africa. It's also important to note that not all the services are available in all regions. So if there is a new service, potentially it will be first available in one of the existing regions, and then it's gonna pop up in all the other region availability. Most of the regions have its own region pair, meaning that, for example, West Europe is paired with the North Europe, and this is because the Azure, when it's rolling out the updates, for example, to the Azure platform, it always rolls out first to the region in one of the pairs, just to make sure that you do not break the platform in case there is a catastrophe, so we can roll back the state. Now, we discussed a bit about the subscriptions which are used for the billing, and let's see now how you can structure them. So in a bigger corporations, you're going to have mostly more than one subscription. And on this picture in right, you can see that there are 3 subscriptions: dev, test, and production. And each subscription is holding the workloads related to the environment. So in dev, you're going to place your development resources that you do not care about breaking. So even if something breaks, it's fine. But then in production, you have the workloads that are serving your business. So all your user traffic is coming into production, and that has to be stable. So then also to segregate the workloads, you want to place them in different subscription for multiple reasons. First, you want to have segregation per environment because of the billing. So you want to know how much your production costs and how much your development costs. And also to enforce the security. So on the subscription level, you can grant different access to different people, meaning that someone can have full access to dev, but can have only, for example, reader rights to production. So in the nutshell, the subscription is security and the billing boundary. Now, when you're using subscription, you're going to have different usage depending on the type of the subscription that you consume. So with pay-as-you-go, for example, you're going to get charged monthly, But for example, with the enterprise, you're going to have one agreement with Microsoft. You're going to pay the fixed price, for example, for a whole year, get the services and a big discount for a lot of services and the software. So to obtain the subscription, you can, as I said, reach out to Microsoft or some kind of partner or reseller, or you can sign up with your personal account that you can brand then to the company one, and you can start right away. So subscriptions are used for the billing and the security. And then we have resource groups. The resource groups are used to logically structure your resources. So in the picture on the right, we see two examples. So the one on the top represents application-centric resource grouping, meaning that if your application has the front end, so that can be some app service, the back end, some SQL database, the storage, and so on, you can group all these workloads together in one resource group because they share the same lifecycle. Or you can have the resource groups per, for example, resource type, and you place then all virtual machines into one resource group, storage into another, and so on. So this is fully up to you how you want to manage your resources. So the resource groups, they logically place your resources, and they also hold the metadata for your resources. You cannot nest the groups, so one resource group cannot contain the other. You cannot rename the groups, but there is a possibility to move the resources between the resource groups. Also, you can apply something called resource locks on your resource groups, and they're there to prevent the accidental deletion of your resources. It's also good to be aware of the resource limits. So the regions have certain resource limit per the resource provider. So here we see the example of total regional virtual CPUs and so something else. So in your subscription, you can go to this blade called usage and quotas to check what is your current resource limit consumption. If you're about to hit the limit, you can open the free support case with Microsoft, and they can extend your limits to the published maximum. So now continuing on the story of the subscriptions. So I mentioned big organizations have a lot of subscriptions, and they can be structured in all kind of different ways. That impose a small issue is that, for example, if you want to grant access to one of your administrators to be able to administer multiple subscriptions, you do not want to go to every single subscription and do the same operational task. Instead, you can create the hierarchy, and that you can do with the management groups. So management groups provide a level above of the subscriptions, so meaning that you can nest or put multiple subscriptions into the management group. And then if you want to grant access to your admins to manage the subscriptions, instead of doing on each subscription, you can do that on the management group level, which is then recursively going to give access to all the subscriptions underneath that management group. Next to the IAM or access management, you can also use the management groups for the Azure policy, so to enforce the governance. And the Azure policy we're going to check in just a minute. Next are the resource tags. So your resources should be tagged with the tags that provide some metadata. So at the right we see the picture where the resources are tagged with key value pairs. So for example, to which environment they belong, or in which department they exist, or which department is consuming this or owning this, and so on. So you can tag your resources to logically have some metadata, but you can also use these tags in your billing lifecycle. So in the billing, you can say, okay, I want to see how much the department marketing is costing us this month. So then you can filter out all the resources that have the tag department equaling to marketing, and that's going to bring together the costs of all of the resources with this tag. To manage the costs in Azure, there is a quite extensive set of tools that you can use for the cost management. It's good to know that costs are resource specific, so a virtual machine is going to be costing you differently than storage account and vice versa, and the costs are going to be different per location where you deploy your resources. Why is that? Well, electricity cost, for example, is different in Europe than in USA and also than in Asia. So there is a human factor, all kind of bills that are different. So that's why you can expect different bill for the resources in different regions. If you want to save on costs, you can use, for example, Azure reserved instances. For example, you can prepay to use the virtual machine for 3 years upfront, and that's going to give you like 30-40% discount if you already know that you're going to be using that. Also, you can use Azure Hybrid Benefit, which brings your own licenses that you consume on premises to the Azure. And also next to that, you can optimize your costs using the alerts, budgets, and the Azure Advisor recommendation. Next up, we'll be talking about the Azure policy. So first, what is the Azure policy? This is the service used to enforce the governance in the Microsoft Azure cloud. When I say governance, that means that you want to oversee what's happening in your organization and also to be in control. So with the Azure policy, you can, for example, enforce to which locations your personnel can deploy resources. So if you operate in United States, you do not want to deploy anything to the Europe regions. So, for example, you can use this allowed locations policy to allow only certain regions where your personnel can deploy stuff. And there are gazillion of these Azure policies that can help you out to enforce certain configurations, such as the security, certain properties of your resources. For example, you can enforce that your virtual machines need to have network security groups in front of them before being deployed, and all these kind of things. So how it works is that first of all, policy is the one unit which defines what can or cannot be done, such as allowing the location or prohibiting something. So each policy is just one setting. In most of the cases, for example, if you want to do the network hardening, then you want to combine many policies into this hardening. So restricting certain protocols on your NSGs, making sure that only private access is allowed, and much more. So then, if you want to apply the network hardening, you need multiple policies. Again, instead of assigning each policy on its own, what you can do is to create the initiative. Initiative is type of a container for multiple policies to group them together and then be assigned at once. So this is a perfect example, like network hardening. Okay, we have multiple policies that we need, we put them into initiative, and then we assign that initiative to the certain scope. Now about that assignment to the scope. So you want to enforce this governance somewhere. So that's going to be either your subscription or the management group or maybe even the resource group. So you can assign these policies to a certain scope in the Azure. So I'm going to walk you through the slides that represent graphical representation of how this is being done, and then we're going to do a short demo in Azure Portal together to see how this can be done. So as mentioned, you have many policy definitions available to you already to use, so you do not have to bang your head against the wall to create these policies. They're already available. Also, there are a bunch of people and organizations that are creating some custom policies, so they're available on GitHub, and you can also import them into Azure. You can also create your own policies if you want so. They're defined in a JSON format, so that's not the problem. So first, we would identify the policies that we want, and then we're going to create the initiative, bundle them together. And then we need to assign that initiative to the scope. So I mentioned that can be either management group, subscription, or optionally the resource group. And after your initiative or a single policy is assigned, it's going to take some time for the Azure to assess your resources against these policies. So basically to determine the level of compliance. Are your resources compliant to this policy or not? And after that, you can see your compliancy in the compliancy dashboard. It's also good to know that Azure Policy has multiple options. So you can either audit what's happening in your environment, or you can either block, for example, certain actions. So, for example, this deployment to the certain regions, you can say, okay, I just want to audit what's happening in my environment by the policy, and then you can see in your logs people are deploying to the certain regions where they shouldn't. Or if you enforce your policy, then they're going to be fully blocked by the policy to do these kind of things. Last but not least, in this module we'll be discussing the configuration of role-based access control. So in Azure we have two types of roles. First are the Azure RBAC roles. So Azure RBAC roles, they manage access to Azure resources. So your subscriptions, resource groups, individual resources such as virtual machines, networks, and so on. And then we have different types of roles, which are the Azure AD roles. They manage access to Azure AD objects. So your users in groups, your devices, and so on. So if you have the Azure RBAC role, that doesn't mean that you can manage the portion of the Azure AD. So you need separate roles at both cases. So what is the role itself? It's basically a collection of permissions that define what you can and cannot do. So on the right we see the contributor role definition, and it says under action there is a wildcard. It says, okay, you can do everything, but then in the not actions it defines what you cannot do. So not actions are stronger than the actions. They basically, when you define them, even though you have here asterisk or the wildcard saying you can do anything, not actions are stronger. So as a contributor you can do everything except authorizing the new users or groups or service principals, whatever, to be able to do something. So there are many role definitions available to you at disposal in the Azure, which are built in, but you can also define your custom roles because they're also in the JSON format. So if it's necessary for your company, you can define the custom roles to accommodate for the certain specific situations that your personnel need. So how it works, basically you would go to the certain scope. So I want to assign, for example, to myself the owner rights to a resource group. So I would go to the resource group, and then I would identify the role, that I want to assign, and I need to choose who's going to be a member of this role. So users, groups, service principals, and so on. And then we assign that role. And the last slide, it's basically describing the flow of the authentication. So once you sign in Azure, you're going to receive first the Azure AD roles. So they're going to give you access to manage Azure Active Directory. And then you're going to receive the RBAC roles, which are going to give you access to manage the Azure resources. What is good to know is that there is a specific role called Global Admin or User Access Administrator. This role can help you regain access to the lost resources. So this is what I mean. For example, your colleague was administrating 2-3 subscriptions and he was the only one who had access. Your colleague resigned and his account is suspended, so no one else now in your organization has access to these subscriptions. What you can do is to become the global admin or user access admin, and that's going to give you elevated access, so kind of a God mode access in the Azure. So you will be able to regain access even to the resources that you are not entitled to directly. All right, let's now see the practical work on how we can assign, for example, some role. So I have my subscriptions here. As you can see, some dev test prod just to simulate the exact company state if possible. And then I want to grant access to one of my colleagues in the dev subscription. So what I would do, click on a subscription and go under access control. And here you can check your own access level, or you can check access level of other people. And you can obviously add roles. So I would say add role assignment. Then I need to identify the role. For example, I want to grant the reader rights to my colleague, and then I need to select who's going to be a member of this role. So, for example, look for some of my friends here in the Azure AD tenant, and then I would review and assign that role. And then under the role assignment, you can check by the role who is the part of this role on this scope. So under the reader, see the Daniel that I just assigned as a reader to this scope. All right, so we ended this module. Because the next one is quite short, let's go over another module and then we're gonna make another break. So next module is about administering the Azure resources. So here we'll be seeing how you can administer Azure with different tools, and we'll be discussing how you can configure your resources with the ARM templates. So in the nutshell, you can manage the Azure with multiple tools. And how is that done? So the Azure has something called ARM, or Azure Resource Manager. This is like the main engine, the brain behind the Azure orchestration. And all the actions are basically sent to this central point, to the ARM. So doesn't matter if you do something through the portal or through the PowerShell or Cloud Shell, the CLI, or you use the template. All of this is then at the end translated into the language that ARM understands, or it's called the Azure Resource Manager language. So at the end, if you're clicking through the portal or doing something through the CLI, it is doing the same thing. It's contacting the Azure Resource Manager and translating that into the language that the orchestrator understands. So then it very depends on you if you're going to be clicking through the GUI or writing scripts or writing templates. Obviously, each of these approaches has its own pros and cons. So through the Azure portal, you would usually do the proof of concept, just clicking around the GUI. But then if you want to go through the full DevOps life cycle and have everything in the code, so what's in the code is actually representing the state of your infrastructure, and then you would go into this direction. But it's important to understand that all these tools are giving the same outcome. So let's see now how we can use, for example, the Cloud Shell. Once you're signed in into Azure, there is this icon of the shell at the top right corner that you can click, and it's gonna spin up the Cloud Shell for you. And there you can choose either PowerShell or the Bash. So depends with what scripting language you're more acquainted with, you'll be using one of those, and then you can administer your resources. What's good here is that because you already signed into the Azure, these tools also sign you into the context of the Azure. So you don't have to do anything. I can already say get AZ subscription, for example, to list my subscriptions that I have at disposal and do many other things. Then in the contrary, we can do something with our local CLI. So now I'm sharing the PowerShell that is available at my local computer. So if I now want to administer my Azure resources from my local computer, I can say, okay, first I need to connect. So I would use commands such as the connect AZ account, which is going to bring me to this portal page where I select the account. It says authentication complete. And if I go back, I see I am signed in. What's important to note is that you always work in a context of a subscription. So when you're manipulating resources, you're doing that in a subscription context. So first you need to set the proper context. Are you gonna manage resources in your prod or dev or test subscription? So first I would say get AZ subscription, which lists all my subscriptions. And there I would say set AZ context, subscription prod, for example. Now when I'm in prod, I can say get AZ resource group, and I can select, I'm gonna get all the resource groups in the prod subscription. So going further, we're gonna discuss now how you can manage your resources using the ARM templates, which is the language known natively by the ARM, this brain that we discussed, main orchestrator. So because every command is translated to the ARM language, you can, instead of writing scripts, you can use this declarative language, which is quite essential for the DevOps lifecycle. So why is it so good? Well, when you're scripting or programming, you're defining the logic, how something is going to be done. So that's kind of an imperative way of programming. But with the ARM, you shift on a different side. So what you do is you write a template. For example, you want to create the virtual network. And in your template, you would state, okay, this is the resource type I want to create, so virtual network. This is the name of the virtual network. This is the scope of the virtual network, so IP range, subnets that it can have, and so on. And what you're doing, you're describing the resource. You're not defining the logic how this resource is going to be created. And then what you do, you send this template to the Azure engine, and it uses the description of your resource, and it deploys the resource on its own. So you don't need to program how something is going to be done. Rather, you can just describe the resource and say, I want this, create this for me. So this reduces a lot of the repetitive tasks and manual interventions, because then you can also reuse your templates. So if you want to deploy multiple virtual machines or virtual networks, you can always reuse the same template to accomplish the same task. So the ARM templates, they are also written in JSON, and the JSON has its own schema. So by default, you need to populate certain properties in JSON to be able to use the ARM template. And then, as you can see here on the right, you can define your resources, define the parameters for the resources, variables, functions, and so on. At the moment, actually, I'm authoring the book on infrastructure as code, and it's going to be released under the name Azure DevOps Explained version 2. So in a few months, if you want to learn more about infra as code, you're free to get the book that we'll be releasing. So the ARM itself can have parameters. What does that mean? So let's take example of provisioning the virtual machine. So when you create the VM, it needs to have, for example, the credentials. So you would use the admin username and the password. You don't want, for example, to have same username and password always at each virtual machine, because that might impose the security risk. So what you can do is to add parameters to your ARM template and then parameterize those values. So whenever you're deploying that template, you can use then different values for the parameters. So have different username and password for each of your virtual machines. So the ARM, it exists already for quite a lot of years, and because it is JSON based, it can grow quite big and complex. So what the Microsoft did, they collected the feedback in the last couple of years, and they came up with a simpler version of this language, which is called Bicep, so ARM on steroids, basically. So what the Bicep provides is same functionality as ARM, but just the simpler syntax for people to be able to write these templates. There are also numerous advantages to Bicep next to the simplification, such as the versioning and how you can write the modules, so deploy multiple resources and so on. If you want to learn about the Bicep more, there is a whole course on the Microsoft Learn. But while in the session, let's have a look at one of the examples. So for example, let's see how we can provision the virtual machine using the ARM and the Bicep. So now I went to the page for Microsoft.compute resource provider, and under this resource provider, one of the resources that it provides are the virtual machines. And then it says choose the deployment language. So you can select, for example, the ARM, and then you're going to see the resource format, how you can deploy this resource. And you can see the JSON, it can grow quite complex and big, quite tedious. While when you select the Bicep, it looks like a Terraform, if someone is familiar with the Terraform. So you can see a very simpler syntax and how you can reference your parameters, variables, user functions, and so on. So Bicep is a wrapper around ARM, basically to simplify the writing of the templates. All right, that's the end of this module. So let's make another break. Let's get off for 15 minutes this time, because we combined some modules, and then we're going to be back to continue with the session. So if you have any questions, please drop them in the chat, and see you all in 15 minutes. Thank you all. Hey everyone, welcome back. I hope you had a nice break, and it's time for us to continue the crime session. So I'll be sharing my screen with you, and in this module we'll be talking about mainly networks and how to administer inter-site connectivity. So we'll be discussing, first gonna give a background of the virtual networks, and then we'll discuss the virtual network peerings, what is the VPN gateway, and at the end we'll cover the express route and virtual WAN. So first, let's start with the network. First of all, when you want to place your Azure workload somewhere physically, you will need the network. So as for example, let's take a virtual machine. If you want your virtual machine to exist in Europe, that means that you need to provision the virtual network in Europe. And that network is gonna literally physically exist in that region. So what is the virtual network? It basically defines the software-defined network existing in your Azure subscription, and it's fully isolated from all other virtual networks that exist in Azure, in all other tenants, in all other subscriptions. So within the virtual network, you're going to have the virtual network space. So let's say that is 10.0.0.0/16. That's the whole space of your virtual network, the range. And then you can carve out that range into the multiple subnets. You would use subnets to segregate the traffic between the workloads, so to maximize the security. You can also use network security groups, which are kind of the access control lists, which allow inbound and outbound traffic or deny it, and to attach that on specific subnets in your virtual network. So whenever you're planning to deploy any kind of workload, first you want to start with the network, because the network gives the connectivity to your workload to be able to reach the internet, but also the other Azure resources. Now, it's very common that your virtual networks are gonna grow in terms of how many virtual networks you're gonna have. And that's very common. So after a few months in your operations, you'll be seeing the need to add more virtual networks. By default, two virtual networks do not communicate one with each other. So there is no communication between the virtual networks. What you need to do is to create the peering. So peering is like a connection between two virtual networks that allows those virtual networks to communicate. So as we see in this picture, there are three VNets or virtual networks which are peered. So first, let's make a distinction between types of the peerings that you can create. First is the global one. So the global virtual network peering connects the virtual networks between two different regions, right? So global peering, two different regions of VNets. And we have the regional peering, which connects the VNets within the same region. In the essence, there is no difference in how these peerings are created. It's just that we identify them differently due to the following considerations. So if you have a regional peering, because the VNets exist in the same region, your communication between the VNets is going to be faster, right? Shorter delay between the packets and so on. While with the global peering, because these two VNets are physically distant actually across the globe, there is going to be higher delay in the transactions that your network is achieving. So when you peer the networks, the communication goes fully over the Microsoft backbone. So your network communication is fully isolated, so you don't need to worry about the privacy because the Azure covers that for you. What is very important to note, and this picture explains it perfectly, is that virtual network peerings are not transitive. What that means? So we have VNet 1 connected to VNet 2 and then VNet 2 connected to VNet 3. That basically means that VNet 1 can contact the workloads in VNet 2, but it cannot use the VNet 2 to talk to the VNet 3. To make this achievable, we need some special device then in virtual network 2, which is capable of routing the traffic. So we need some kind of device that knows how to route the traffic between the virtual networks to understand what is the source and what is the destination and how to send the traffic towards the proper destination. So next slide explains how we achieve that. So here on the right we have pretty much the same situation, just a bit more components. Maybe looks a bit complicated at first glance, but it's not. So there we had VNet 1, 2, and 3, and here we have VNet A, B, and the hub VNet. So hub VNet is going to be used as the virtual network that replace our devices that know how to route the traffic, and then we can use this virtual network to contact others. This is architecture called hub and spoke, or topology called hub and spoke. And how it works is that you have one central hub, and in that central hub you're going to place, for example, your firewall. And then all other spokes, so all other VNets that contain your workload, are going to be peered to this network. So that means if I want to contact from VNet A to VNet B some workload, I need to go through hub VNet. And this brings a lot of benefits, because if you're always peered to the network that has the firewall and some other devices which are filtering the traffic, that means that we have one central place where we can administer what is allowed to go where. So then you can imagine thousands of more peered networks next to this A and B peered to the hub, and then you can basically say, okay, VNet A is allowed to go to VNet B, VNet B is not allowed to go to VNet C, and so on and so on. So we use this hub and spoke topology as the best concept, best architectural networking pattern to allow this kind of communication in the Azure. So if you want to route the traffic only between the networks that are in Azure, you can place here the firewall. But if you want, for example, to route traffic towards your own premises that are also maybe connected towards the Azure, you need to place there the VPN gateway, which can help you out to go, for example, to your own premises. So let's see now through the graphical representation how you can create the VNets. So it's very simple. What you need is to have source and the destination, pretty much, and to name the links between them. So source to destination and destination to source, something like that. So if you're then connecting, for example, your VNet to the hub, which has the some appliance inside to route the traffic, you can, for example, say use the remote virtual network gateway. So your network already knows that there is gateway in the destination hub that can be used to route your traffic. Now on the right we see the same scenario. So hub VNet, some appliances inside, and we have two VNets, VNet 2 and VNet 3 paired to the hub. So we want to make sure that VNet 2 is able to reach the VNet 3. So it would need to go through the hub, and then hub would send the traffic towards the VNet 3. Now what the issue is here is that it doesn't matter that you paired this network, how this VNet 2 knows how to reach the VNet 3, because VNet 2 maybe has also some other direct peerings with other networks. This is where user-defined routes come into the play. So what you can do is to create the routing tables where you say, okay, to reach the VNet 3, you need to go first to the hub or some appliance in the hub. So this is called actually the service chaining. Service chaining enables you to direct traffic from one virtual network to a virtual appliance or to virtual network gateway in a paired virtual network through the user-defined routes. I may assume that people that do not have such a strong background in the networking might have some difficulties understanding these concepts, and that's why I'm going to encourage you to spend some more time studying networking, because this is very, very essential for your career. So if you do not understand networks, you're not able to build the systems, because you need network, then you need something in that network which is going to run your application or whatever. And obviously, if you have any questions, please drop them in the chat so we can catch up on your doubts. Next up, we'll be discussing the configuration of the VPN gateway. So first of all, what is the VPN? VPN basically translates to virtual private network. It is the tunnel that you can create from one point to the other and then send encrypted information through that tunnel. So the example would be if you're employed in the company, right, and your company doesn't allow public access, so you cannot access your company resources over the internet, they would set up the appliance that you can connect to using the VPN. So you would connect from your home to the device which terminates the VPN tunnel, and you're gonna get the IP address at your device like you're in your company. So you can work from home and manipulate your company resources even though you're not physically present in the company network. So in Azure, we can provision a VPN gateway to be able to facilitate the VPN connectivity. And there are three main patterns for the VPN connectivity. So first one, let's mention this site-to-site, which connects basically your whole site towards the Azure. So the example would be, okay, you have your company, you have some data centers already, and you start consuming cloud. So you want then privately your servers and applications to be able to contact what you have in Azure now. So they cooperate, basically, they work side by side. So you would provision the tunnel from your company towards the Azure VPN gateway so that your company resources in your data center can communicate with your resources that you spin up in the cloud. So that's classical site-to-site. Then we have point-to-site, where individual device, as you can see here, the user can connect towards the VPN gateway and then gain access to the resources. So if I'm working from home and I need access to the company resources in Azure, I would then connect from my company computer to the Azure VPN gateway to gain the access. And third, and well, not so common one, is to create the tunnel between two virtual networks. So if you install the VPN gateway in two VNets, you can also then create the VNet to VNet tunnel. This is not necessary because you have VNet peering, which we just discussed, that you can use, but because VPN gateways are meant to create tunnels, there is also option to create tunnel between two distant VNets if you want, obviously, for whatever reason. So now we're going to go through the process of provisioning site-to-site VPN connectivity, see how we can do that. So you have your on-premises, you have your data center, and you have something in Azure Cloud. You want this to cooperate. Let me just switch on the light so you can see me properly. All right. So first, we need to start with the network. So same thing that we discussed as for the virtual machines. So we would provision the network and the subnet for our VPN gateway. So looking from the network pattern, I would place that in the hub network, because then from the hub you can connect to all your peered spoke networks. So you would provision the gateway subnet, and you then need to place the VPN gateway into that subnet. Okay, so then we have the VPN gateway in Azure, and we want to provision site-to-site towards our on-premises. How Azure connects to your on-premises is that it doesn't connect directly to your device, to your firewall, for example. Rather, it connects to something called local network gateway. This is the resource that is also provisioned in Azure, but it represents your local on-prem device. So you would create the local network gateway in Azure, and this local network gateway is going to receive the IP address and the FQDN of your on-prem device. And then you would establish the connectivity between those two, while you still need to configure, obviously, your local on-prem device. So now let's go through those phases more deep in depth. So first, we said you need to provision the subnet. So your subnet needs to be at least /28 or /27, and you do not want to place any other resources, any VMs or whatever, into your gateway, because your gateway can scale, meaning that if tomorrow you need more VPN connections, more point-to-point or more point-to-site, you want to leave this network space free for your gateway to add in the backend additional instances of this service, so you can support more tunnels for you. So we will provision the VPN gateway basically, then in our network. So you need to choose basically what kind of routing you want. Do you want to go with route-based or policy-based routing? And you need to assign the public IP to the VPN gateway. What's good to note is that this is a quite huge resource, and it can take up from 45 minutes, 30 minutes, up to 1 hour to provision it. Your gateway has a different SKU. SKU is like the model kind of your service, and the higher the SKU, more capabilities you have. So as you can see, just the basic SKU supports 30 site-to-site tunnels, while the latest and the greatest SKU supports up to 100 tunnels. Also different throughput benchmark and number of point-to-site connections. Now this guy that I talked about, the local network gateway, so that's the resource in Azure that represents your local network device. And as you can see, you would put the public IP of your local network device or the FQDN, and you would also state the IP address prefix, which is going to be routed through the gateway towards your VPN device. For your on-prem device, well, you need to consult the vendors and device families which are supported to be represented by the Azure Local Network Gateway. So at the point of creation of this slide, you can see Barracuda, Cisco, Citrix, Juniper, and so on. Maybe the list has grew a bit more. So if you're in a situation to provision site-to-site tunnel, first consult the documentation. So
Hello, Nemenj.
yes,
Sorry for the interruption. So can you
yes.
please check the query of Owen?
Sure. I'll be coming back to his query once we are at the micro break. So I'll be discussing the question with him directly once we finish the module.
Okay, Nemenj.
Just not to interrupt the pace. I'll come back to you, no problemo. So once we have configured the device on premises, we have the VPN gateway in place in Azure and the local network gateway representing your on-prem device, you will be then provisioning the VPN connection, basically. And that's going to be the classic IPsec for site-to-site tunnels, and you'll be using the same pre-shared key at your own premises and also in the Azure. There's some scenarios where you definitely want to have high availability, so you can go as on the left with active standby, which is the default setup scenario for the site-to-site. So you would have two VPN gateways in Azure and one of your devices at on-prem. So if your connection fails, then you will need basically to switch to your standby. And if you want to have active, well, that's gonna bring definitely higher availability, but also it's gonna bring more costs, because at your own premises you need then two devices, and in Azure you need two devices. And then what you can do is to create these cross tunnels, so each device is gonna have tunnels to both of the VPN gateways, which means that if any connection goes down at any point, you still have the active setup. All right, now we'll be discussing the express route and the virtual WAN, which are the last in this module, and then we're going to make a break and I'll be discussing all of your questions with you in the chat. So now we have been discussing the VPN tunnels. VPN tunnels are good. They enable you to have communication between two distant resources and to give access to the networks behind them. But what the problem is with the VPN is that they're software based. So software based tunnels do not give you ability to have high throughput benchmark. So this is where the express route comes into play. So the express route is the service that enables you to expand your on-premises towards the Microsoft Azure cloud. So basically to create connectivity from your on-prem to the Azure, but using the physical infrastructure. So I'm going to give you one example. Imagine that I live, for example, in the Netherlands, in Amsterdam. And in Amsterdam, there are a bunch of these partner edge companies that provide connectivity, such as Verizon, Equinix, and so on. And all of them mostly are partners with the Microsoft. So let's imagine I have my own data center in Amsterdam, and what I can do if I have resources in Azure, to be able to connect them, I can go to one of the partners and say, okay, I want to provision the express route. And what they're going to tell to me, okay, sure. First, you need to bring the cabling from your data center to ours. So I would literally go buy the fiber optics, and then have the cables going from my data center to the partner, which exists in the city where I'm placed. So I connect physically from my data center to theirs, and what they do is that they then have direct connectivity to the Microsoft Edge, which are the routers that facilitate the connectivity towards the Azure and different Microsoft services. So As you can see, the express route also gives you the private connectivity to your Azure resources, but using the physical infrastructure. So nothing goes over the internet, still uses fully the Microsoft backbone and the partner Edge network, but it's much more potent in terms of how much traffic can go through this, because it is utilizing the physical infrastructure to extend your own premises. So these are some capabilities of the express route. First, it is a layer 3 service, so it works on the network layer of the OSI model. By default, when provisioning the express route, you can connect to all the regions within your geography. So if I'm in Amsterdam and I go to this partner, I'll be able to connect to all the Azure regions that exist in Europe. And if I want, then, for example, to utilize this partner to connect to the USA region using my express route, I will need the express route premium add-on for the global connectivity. Then there's some other stuff, like there are different billing models. So you can, for example, prepay on a monthly basis for unlimited traffic. So you're going to pay a bunch amount of money, but then you're going to have unlimited transfer. Or, for example, they're going to meter your traffic. So depending on the inbound and outbound traffic, you're going to receive the metrics and the bill for that month. And the express route supports the bandwidth options from 50 megabits up to 100 gigabits per second, which is quite fast. Your express route can also coexist with site-to-site VPN, just for the sake of the high availability. But in really enterprise companies, what I see is that they actually allocate funds or money to set up dual express route connectivity. So to have basically two express route setups per the environment in case that one goes down, that other one can take over. This is especially the case when the VPN tunnel cannot support that amount of traffic. So if you have, I don't know, 100 gigabits going through your express route, your VPN tunnel is not going to be able to afford that kind of connectivity. So this table, it compares the connectivity options that we have, and let's see some of them. So all of them we discussed. Let's start with the express route. So express route is used in enterprise class mission critical workloads and for big data solutions. So it has a bandwidth from 50 megabits up to 100 gigabits per second. Then we have site-to-site tunnel, which can be used for some small-scale production workloads, and typically it's up to 1 gigabit per second. And then we have point-to-site, which is used for some dev test labs or individual machines to be able to connect to the cloud. All right, last but not least, let's discuss the virtual WAN. So we discussed the hub and spoke model, and we discussed the VPN connectivity, also the express route. Virtual WAN is the technology that brings all of these together. So in hub and spoke topology, you need to administer your hub. So in hub, you need to place your VPN gateway, you need to place the firewall, and then later you need to create the express route, to interconnect all of these, to manage the VPN gateways, to manage the express route gateway, and so on. The virtual WAN is the service that says, okay, we're going to manage all of these for you. So you can provision the virtual WAN, and what it gives you this hub network, which you can use to peer your networks to, and then it's going to automatically facilitate the routing between the networks, and it also maintains for you the express route, site-to-site and point-to-site gateways within that hub. So you don't need anymore to provision VPN gateways. You can just now say, okay, I want to connect to my virtual WAN from on premises. You already have everything ready inside. So it is kind of a technology that brings all of this that we discussed together, but instead of you managing these devices, it manages all of this for you, and it's really great. I encourage you to play with it. It's quite sophisticated technology because it brings all of this together, but it's very, very useful because it offloads quite a lot of administration and the overhead. So that would be the end of this module. We're going to go for a break and I'll be answering your questions. So I will see you all in 10 minutes. Okay, everyone, welcome back. So we'll be continuing the cram session. Hope you had a nice break. All right. So in the upcoming module, we are still staying with the network, and this time we'll be discussing how you can administer the network traffic. So we'll be discussing the network routing and the endpoints, Azure Load Balancer, Application Gateway, and the Network Watcher service. So by default, when you provision the network in Azure, it needs to communicate with other resources, maybe in the same network, maybe in a different network, or with the internet. So to make this possible, Azure already pre-creates for you something called system routes. System routes are there to route these default patterns that exist from your virtual network towards the destination, such as the internet or other virtual networks. We already discussed this, but let's repeat. So you can alter how the network traffic is going to be routed using this user-defined routes. User-defined routes let you create the custom routes that you can attach to your subnets, and then that's gonna enforce your network traffic to be routed in a different way. So user-defined routes can override the system routes, but the system routes you cannot change and you cannot delete, basically. So that's good to know. Now, it's speaking about the security. So very often it happens that we have the requirement to access some service privately in the Microsoft Azure, so not going over the public internet. Service endpoints are giving us one of those abilities. So looking at the right, let's explain the use case. Imagine that you have some PaaS resource, so platform as a service. It can be your storage account, SQL database, function app service, whatever. So you have that in Microsoft Azure. And that has the public endpoint, which is the public DNS name, so everyone can actually target it. And in Azure, you have some other virtual network where your virtual machine exists. Now let's create a short scenario. So your security department came to you and said, we have the requirement to route all the traffic through the Microsoft Azure backbone and not go over the public internet. What you can do is the following. You can enable the service endpoint in your subnet, and service endpoints relate to, let's say, service providers. So you can see here on the right, there is Microsoft Storage, for example, which is one of the service providers. And if you enable the Microsoft Storage in your subnet, that means that all the traffic destined to storage accounts, because they fall into Microsoft Storage service provider, is going to be routed over the Microsoft backbone instead of going towards the public internet. So all the traffic, not just towards one of the storage accounts, but towards all of them, is going to be now routed directly from your virtual network over the Azure backbone towards the storage account. That also means that you will need to whitelist the virtual network sources at the destination cell. So in the storage account, you will need to create rules where you allow these virtual networks to access your storage account. So in this case, your VM is going to use its own private IP to access your storage account, but it will be still targeting the public endpoint. So the public endpoint is not going to be removed. You will be still accessing public endpoint, but fully over the Microsoft backbone. Now there is a different use case. Your security department came and said, okay, we want fully the public endpoint to be removed. So we want that you can access your storage account or the SQL from your network directly into one of your networks. So in this case, what we can do is to create private link and private endpoint. So private endpoint is a network interface that you can provision for your subnet, same as network interface for your virtual machine, and then you can link that interface or the private endpoint directly to one of your PaaS resources, so the SQL or the storage account, for example. And then, instead of having the public endpoint, now your resource that you need to access your destination has the private endpoint with the private IP address directly in your network. This is also going to help you out then from the Azure towards the Azure. We're going to explore that in a bit more. So now understanding what the load balancer does, let's see some of the solutions that are available in Azure to us. So we have layer 7 load balancers, which are the application gateway and the front door. So they work over layer 7, which is the HTTP. And basically they manage web requests towards your applications. Then we have the load balancer, which works on the layer 4, which is TCP and UDP. So it can load balance the traffic on various ports for you. And then we have the traffic manager, which is DNS-based load balancer. Now we will be focusing on this third column, which is the load balancer itself. So there are two types of layer 4 load balancer. There is a public load balancer. So it basically load balances the traffic coming from the internet towards the load balancer back to your servers that are behind the load balancer. There is also a different type, which is called internal load balancer. Internal load balancer can load balance only the traffic coming from Azure destined towards the Azure. So this is great when you have the multi-tier applications, such as, for example, here we have the VMs, which can be some kind of front end for your application. And then you have the database, which is storing, for example, user data and so on. So you do not want at any cost your databases to be accessed by the public internet, because that's where the data is, you can put the load balancer in front of your workloads, so in front of your VM between the, the database tier, in order to load balance the internal requests. And in this way you can build very hybrid infrastructure. So load balancer, it has two SKUs. The basic one, which is, well, as it says, basic, so you do not have any SLA on the basic load balancer. Also, it supports up to 300 instances in the backend pool. There is also standard, which has 99.99% SLA, and it gives you up to 1000 instances in the backend pool. Also, you can use the HTTPS for health probes. Now, we have created the load balancer, and now we need to put something behind the load balancer towards what we're going to destine our traffic. So in load balancer terms, that's called the backend pool. So in the backend pool, we can place our backend servers, and as discussed, depending on the SKU, you'll be able to put number of instances in the backend pool, and also that's going to differ if you're able to put, for example, VM scale sets or single availability set, obviously depending on the SKU. Now the load balancer has rules, obviously, and the rules are one that are enforcing the logic, how we connect the traffic that comes to the load balancer back to our backend pools. So rules, they map front-end IP and the port to a backend pool and the port. As you can see here, so we have front-end IP, which is a private one, so I can tell this is the internal load balancer, and it maps the port 80 to a port 80 also in the backend pool B01. So whenever traffic comes on port 80, it's going to be mapped to this backend pool and the backend port. Next up, we'll be discussing the Azure Application Gateway, which is also a load balancer, but a bit of a different type. So what the Application Gateway does, it also load balances, but the web app request. So it routes traffic which comes from the internet over the HTTP to a web servers based on the URL of a request. And here in your pools, you can put Azure Virtual Machines, scale sets, and also Azure App Services, also your on-premises servers. So let's see now how the Application Gateway can route these requests. So first, there is path-based routing. Path-based routing looks into the path within the URL, and based on that decides where the request is going to go towards which backend pool. So in this case, we have the website contoso.com and two paths /images and /video that, depending obviously on the path URL, are going to go to two different backend pools. So there are servers that are hosting images, and there are servers that are hosting a video for contoso.com. And there is this different way, which is called multi-site routing, and Application Gateway in this case looks only at the top FQDN in the URL. So in this case, contoso.com or fabricant.com, and the application for the whole website goes to two different backend pools. Right. Next up is the Network Watcher in this module, and Network Watcher is the essential service in Azure to troubleshoot the network connectivity problems. So if you have a problem with reaching the destination, having the issue with network security groups or the routing, this is the service to go. So network watcher. So basically, suite of multiple services within one service that can help you to troubleshoot the network traffic. Some of them are like next hop, VPN diagnostics, topology, and so on. So now we're going to see a few of them more in depth. There is IP flow verify diagnostics. So with IP flow verify, you can check if the traffic is allowed or denied from local IP address towards the remote IP address. And this diagnostics is going to troubleshoot if the traffic is passing by, and if it is or it's not, it is going to show you the security rule in the respective network security group, which is allowing or denying this traffic. So in this case, you can troubleshoot why your traffic is being blocked. Next up, we have next hop diagnostics. This tool helps you to determine if your traffic is being directed to the intended destination, basically, by showing you the next hop. So you can specify the source virtual machine and the destination IP. And if you click on next hop, it is going to show you what is the next hop type and the IP address of that next hop. So this way you can troubleshoot the routing issues. And for example, we have network topology, which can help you out visualize your networking infrastructure. So how your virtual networks are peered, interconnected, what is connected in your network, so which interfaces, what is behind the interfaces, so for example VMs, their public IPs, and the network security groups, as well as route tables that might be attached. So that's the end of this module, and we're going to another break. So I'll be seeing you all in 10 minutes, and then we'll be continuing with the cram session. Hello everyone, welcome back. Hope you had a nice break. It's time to continue. Well, I hope no sharing problems at this point. If you do not see my screen at some point, please let us know. Alright, so in this module we'll be discussing administration of the Azure storage. And that focuses on configuration of the storage accounts, specifically blob storage, storage security, and Azure Files and file sync. So first, Azure storage. In Azure, we can create storage accounts, which are one of the Azure storage services that can store different types of data. The storage accounts can store unstructured, structured data, and for example, virtual machine disks. And it comes in two tiers, premium and standard. So now let's see how the storage account is structured and how it helps us to store the data. So on the right, we see the storage account that is created, and in storage account, you can provision different storage types. So for example, in the container, you can store blobs. Blobs can be images, documents, video, audio, any type of binary large object. Then you can provision table and store entities inside. Well, you can think of this as the Excel table, for example. Then there is queue, and inside you can store messages. So messages for example, microservices application architecture. You can provision files, and inside the Azure files, you get basically hosted file shares where you can store the directories and the files. So containers are for unstructured data, tables, ideal for storing structure and non-relational data, queues, messaging, store for reliable messaging between application components, and Azure files for managing of the file shares hosted in the cloud. So when you create a storage account, it's going to ask you for the storage account kind. And there are 4 kinds. First and the most common one is the standard general purpose V2, which can hold or store the data of all the types. So blobs, files, queues, tables, and data lake storage are supported. Then you have the option to go premium. If you select the premium storage account, then that premium is going to be able to store only certain type of data, just to kind of focuses and specialize in hosting that one type of data. So you have premium block blobs, premium file shares, and premium page blobs types of the storage accounts. With the storage accounts, you can also replicate your data. So there are different types of strategies that you can use to replicate your data. You can replicate data in a single region, in multiple regions, and also you can go advanced, like for example, to have the replication in first region across multiple availability zones, then to the secondary region in the multiple availability zones, and also secondary would be the read-only replica of your data. So there are different replication strategies that support different types of SLA requirements, I would say. So you would replicate to increase your SLA and the fault tolerance on your data. Because the storage account in itself can store different types of data, you will be accessing those data types across different endpoints. So the container, for example, which is hosting the blobs, will have the endpoint, which is your storage account.blob.core.windows.net. While, for example, the hosted file shares in the same storage account are going to have different endpoints, like your storage account .file.core.windows.net. You can also configure the custom domain name for your storage account. You can secure your storage endpoints. So we talked about the service endpoints in the past, and this is where it applies also. So you can open the traffic towards your storage account from the public IP or from your virtual networks, for example. So there is an integrated firewall in the storage account that helps you out whitelist the traffic or block it, obviously. Next up, we'll be talking about the blob storage. So blob storage stores unstructured data in the cloud. So that can be, for example, serving images or documents directly to a browser, having files for distributed access, streaming video and audio, and you can also use it for backup and restore operations or for data archiving. To store the blobs, you need to create the container, and on the container you can also define the level of access. So, for example, you can define public access, or you can define access to the container or to specific blobs. The data in the blobs can be applied to different access tiers. Actually, way around. Access tiers can be applied to your blob data. So what does that mean? You probably will have different kinds of blob data in your storage account. So images, video, backup data, logs, and so on. So if you need that data to be accessed very frequently, it needs to be in a hot tier. That means that you can instantly access your data, but you're going to pay a higher cost for your data being in the hot tier. While, for example, in the archive is optimized for storing data that can tolerate several hours of retrieval latency, but that means that you're going to pay less for that data. So, for example, you can put logs which are, for example, 2 years old into archive data, which you don't need to access instantly into the archive tier, and you're going to pay less for this amount of data. What is great is that there's something called blob lifecycle management rules. So with these rules, you can transition your blobs to a cooler storage to optimize for performance and cost. So you can define that all the blobs that are older than X amount of days would go to the cooler storage, or maybe to the archive storage. And you can also delete the blobs at the end of their life cycle. So if you have log retention of 5 years, you can say, okay, all the data older than 5 years can be deleted. You can also replicate your blobs across different destination storage accounts and their containers. This is obviously asynchronous, and it is basically optimized for data distribution and access. Next up, we'll be talking about the storage security consideration in the cloud. So there are multiple strategies and approaches that you need to apply in order to secure your storage. So there is a storage service encryption, authentication, disk encryption, shared access signatures, and more. Let's start with the shared access signatures. So imagine that you have a colleague that needs to access your data in the storage account only for 1 day, and the revocation of his access needs to happen automatically after 1 day expires. So what you can do is to use shared access signatures. With SAS or shared access signatures, you can define the set of permissions and the start and the expiry time of these permissions add a specific container in your blob storage. So this is going to generate kind of the URL that you can send to the person or use it in the application to access the data. And with the SAS token, you basically define specifically what this person or the system is going to be able to do with the data over these tokens. So maybe just to read the data, to write the data, to delete the data, and so on. And after the SAS token expires, the permissions are automatically revoked. So this is how the SAS token looks like. It's like a red URL. Basically what you see inside is a signed URI that consists of the URI and the SAS token. And inside you can see the storage service version, resource types, start time, expiry time, permissions, IP range, and the protocol and the signature. So you can also say, okay, I want people only from these public IPs to be able to reach the storage account using these SAS tokens. So you can be even more specific. Then we have the storage service encryption. So your data in Azure Storage is encrypted by default, and you cannot disable this, meaning that Microsoft enforces the encryption of your data at rest automatically, and it's encrypted using the 256 bits AES encryption. You can be more specific by saying, okay, we want to apply the encryption, but we want to use our own managed keys to support the encryption. So that means that you can have your own keys in Azure Key Vault that are going to be used for storage encryption, and you can use also Key Vault APIs to generate new encryption keys. So to stay up to date with your keys in case you are paranoid of them being disclosed, right? So your custom key is going to give you basically more control. All right. Next up, we'll be discussing Azure Files and the file sync. So first, let's compare Azure Files to the blobs. So blobs, we said, they're unstructured data, audio, video, and so on. While the Azure Files, these are just the file share hosted in the cloud. So as you can host a file share on the file server, you can also do that in the Azure cloud. And you can actually map this to multiple operating systems then. So once you provision the Azure file share, you can come to this connect screen, which lets you select which operating system you're utilizing, and it's going to generate the connect script towards your operating system, meaning that you don't need to worry about how you're going to connect to this file share, but the Azure gives to you already the way to connect with the pre-made script. There is also possibility of using the file share snapshot. So if you want to revert your file share state to point in time back in history, you can use the snapshots, which basically provide the read-only copy of your data, and they're great if you need to revert to the state back point in time. Next up, we have Azure File Sync. So if you want to centralize your file shares from multiple locations towards the Azure, so if you have your company already multiple cities or whatever, and you have many file shares, you can use Azure File Sync to sync your file shares towards the Azure files. So this is great for lift and shift migration towards the Azure file shares, for branch office backups, file archiving, and more. To set up the Azure File Sync, it's quite simple. You deploy the sync service then you would basically make sure that you know what you want to sync from your Windows servers, install the file sync agent on your Windows server, register that server, and then you would create the sync group basically between the file shares locally on your Windows server and the destination file share in the Azure. And to interact with the storage, you have multiple tools also at your disposal. So there is Azure Storage Explorer, which is a graphical interface which you can use to connect to your storage accounts and manipulate all types of data inside. So both blobs, files, pages, tables. You can use AZ Copy. So AZ Copy is command line tool to copy data to and from your storage accounts. And you can use import export service to import and export a large amount of data to and from the Azure. All right, that brings us to the end of this module. So we'll be making another short break, 10 minutes, and then we'll be continuing with the session. So see you all in 10 minutes. Okay, everyone, welcome back. So we are continuing our crime session, and in this module we will be discussing the administration of the Azure virtual machines. So we'll look at how you can configure the VMs, the VM availability, and virtual machine extensions. So if you went through the AZ900 course, this slide might be familiar to you. It represents the responsibilities between the Microsoft and the customer depending on the infrastructure type that you're consuming. So gray boxes is the Microsoft and blue boxes is you or the customer. So since we are focusing on EOS, where the VMs are falling in, we're seeing that Microsoft is operating the physical host, network, and the data center, and that we as a customer, we have responsibility to take care of operating systems and everything above, so network controls, applications, and much more. So when setting up the VMs, you again want to start with the network, name your virtual machine, choose the location, and also you must consider the pricing depending on the region when you're deploying your VM. The VMs come in different types, so you can select general purpose or maybe some more specialized types of the VMs, which are either compute memory, storage, or GPU optimized. There are also, I believe, many more. Each virtual machine has 2 or more disks attached to it by default, so OS disk and the temporary disk, and you can attach as much as you want data disks to your VM, and the disks can be either HDDs, SSDs, or premium or ultra SSDs. To connect to your VM, you can use the Azure Bastion, which is the service broker, I would say, for your connections. It is great because you place it in one of your virtual networks and then you connect over it using the TLS over the internet. So it's a fully encrypted channel, and the Azure Bastion is then brokering the connections using the private IP towards the RDP or SSH, obviously depending on the type of the VM that is behind. Next up, we'll discuss the VM availability. So there are different types of maintenances and downtime that can happen in the cloud. In case there is an unplanned hardware maintenance, the Azure is going to issue the live migration. In case there is unexpected downtime, actually the Azure platform is going to try to automatically heal your infra. And with the planned maintenance, there are no actions. You can place your VMs into different availability zones within the region. So that means that your VM is replicated across the data centers that use fully isolated, independent power, cooling, networking, and so on. So if the one availability zone crashes in the region, your VM is still fully operating in another availability zone. You can scale VMs either vertically or horizontally. Vertical scaling, also known as scale up and scale down, is the process of adding more compute resources to your virtual machine. While the horizontal scaling, also known as scale out and scale in, is about adding more instances to the cluster of your VMs to support your workload. You can create scale sets which are going to scale your VMs automatically from 0 to 1000, and you can choose the size of each virtual machine in the scale set basically. You can configure the auto scale in the scale set to scale your VMs based on the rules, and you can define minimum, maximum, and default number of VMs, and also then create rules based on the CPU threshold, so you can scale or scale in on demand. And last but not least, we'll be discussing the virtual machine extensions. So the VM extensions are the applications that provide post-deployment VM configuration and automation tasks. So they're different for the Linux and the Windows because those are two different operating systems that support different automation. So depending on the system, you will be able to install some extension, and that extension can be used to run post-deployment configuration. One of the examples is, for example, custom script extension. So this means that you can run any type of custom script on the virtual machine after it's deployed, and it can run up to 90 minutes. So if you need to perform any kind of configuration tasks, you can use this extension. The next example would be the desired state configuration. So desired state configuration is kind of the ARM that we discussed, but for the Windows Server. So you can use DSC to declaratively define your infrastructure. So here we say that we're basically installing the web server on the Windows Server using the DSC. So you can then run this code using the extension after the VM is deployed to configure the web server on your virtual machine. All right, that brings us to the end of this module, and as usual, we're gonna make a break. So if you have any questions for me, please drop them in the chat. Let's make a short break of 10 minutes, and then we'll be continuing with the session. Okay, everyone, welcome back. So we have 50 more minutes to go over the content which is remaining, and we're gonna have some time for Q&A at the end. So I'm sharing my screen with you, and we'll be going over administration of the platform as a service compute options. Here we'll be discussing the Azure App Service plans, Azure App Service, container instances, and the Azure Kubernetes Service. So first, starting with App Service plans. App Service plans are basically the set of compute resources for your web apps to run. You can see it as servers, basically, to run your app services. Depending on the app service plan that you have, it determines the performance, price, and the features that you're going to receive. And in app service plan, you're able to host one or more of your web apps. Web apps can be completely different if they're .NET, Java, or whatever, but it's important that they share the same operating system type, which app service plan also defines. So in app service plan, you have different SKUs also, so the free one doesn't give much, but if you go with the standard or premium, you get a lot of disk space, a lot of instances to spin up. Also, you can go with dedicated compute basically for your applications, and that also brings some other features related to security and branding. Depending also on the app service plan that you have, you can have automatic scaling. So you can scale up, change actually the app service plan type, or you can scale out, basically increasing the number of these instance count in the cluster of your app service plan. To auto scale, you can define metrics such as the CPU, memory, and HTTP requests. You can also combine that with schedule based on the weekdays, and based on the mix of these metrics, you can create very good schedules for the scaling. So now when we know what is hosting our app services, let's find out what are the app services. So app services are PaaS offering, which give you ability to develop web apps, API apps, mobile apps, and the function apps. They're fully managed by Azure, meaning that you can focus only on writing your application and not caring about underlying infrastructure. And they support .NET, Java, PHP, Python, and so on, basically. So to create the app service, you need to have a unique name, because this is going to be a unique DNS name, and you can also map then later on your custom domain. You need to define the runtime stack, so this is going to be the language which is going to be used for your app service, and the app service plan on which it runs, and that also dictates if it's Linux or the Windows based. App services have one very cool feature called deployment slots. So imagine that you're releasing a new version of your application into the production. So you don't want to overwrite your production right away, even though it might go through multiple environments with the deployment. Rather, you want to deploy to a slot. Slot is like instance of your application next to your production, but in the same app, where you can deploy the new version of your app and test that across just a few users. So once you're sure that new version of your application is working, you can swap it for the current production. So the production is going to become staging, and your staging is going to become production. This also means that if there are problems, you can switch instantly to the last working version of your app. You can secure your app service by implementing the authentication, and also you can, for example, add SSL certificate and also brand with your own domain. You also want to store all the secrets related to the configuration in the key vault and not in any plain text file. You can also back up your app service, meaning that you can either manually or schedule the backups. You can either back up the full app service, or you can also cherry pick what you want to back up, which files and folders. Next up, we'll be discussing the Azure container instances. So the container instances are basically also managed orchestrator for your containers. But first, let's see what are the containers in comparison to virtual machines. So as you can see in this picture, your VMs are running on top of hypervisor in your host operating system. And then they have fully installed guest-OS. While the containers, they don't have separate operating system, but they run on top of your host OS, and then they share the same kernel, meaning that they have their isolation in the run space so that you can still deploy to your container apps with the separate binaries and libraries, like it is treated as a separated operating version system, but it is actually not. So they're way faster because they don't have this hypervisor and the guest OS layer between. So they run on top of your operating system. With the container instances, well, it's a PaaS service again, so it's managed by Azure. You have isolation features, so you can isolate your containers between the images and how you deploy into container instances. You can attach the persistent storage. You can have both Linux and Windows containers, and you can also deploy these fully isolated in your virtual network. How it works is that your container instances can contain container groups. This is similar to pods as in Kubernetes. So container groups are top-level resource in container instances. It's basically a collection of containers that get scheduled together on the same host. So if your app has front-end, back-end, and some other components, or each component can have its own separate container, and then they get co-scheduled in the container group on the same host. That means that they share the same lifecycle, resources, local network, and the storage volumes. And next up, we'll be discussing the Azure Kubernetes service. So Kubernetes is a bit different than container instances because it's a bigger orchestrator. It's meant really for the enterprise hosting of the containers, and we need to get into some terminology first. So first we have pools, which are basically also like these container groups, which are a group of sorry, I started talking about the pods, but let's go one step back. So first we have nodes, which are actually the VMs which are empowering your clusters, right? So as we can see here in the picture, there are the nodes behind your cluster which are running your workloads. Then we have pools. Those are the group of these nodes with the identical configuration, basically. And then we have pods. Pod represents a single instance of your app, and it can be comprised of multiple containers, same as container group in container instances. So multiple containers scheduled together. Then we have a deployment, which is one or more identical pods managed by Kubernetes, and the manifest, which is the YAML file describing the deployment. So the AKS cluster is empowered by the nodes, which stands behind your cluster, and there is obviously a virtual network which can interconnect your nodes. So Azure Managed Nodes provide core Kubernetes service and orchestration. You can have also customer managed nodes that can run applications and supporting services. So meaning that if you have managed Kubernetes, the Azure is managing those virtual machines which are running the Kubernetes cluster, and your nodes are the ones that are running the applications, basically. So core functionalities of the Kubernetes hosted by Azure, and then your nodes are running your apps. When it comes to the networking, there are few different, let's say, networking patterns in the Azure terminology. So your pods are going to run your instance of your application, and when connecting to the pod, there are different traffics. So you have internal traffic, incoming direct traffic, and incoming non-direct traffic. All of this traffic is, let's say, being destined to your pods in different ways depending on the traffic type. So they're either going to go through the load balancer or through the AKS node or directly to the cluster IP. And when it comes to the Kubernetes storage, so you have the option to have the local storage attached obviously to your nodes, which is fast and simple to use. And it can be persistent basically, but also the local storage might not be available after the pod is deleted in case it is not persistent. So you want to make sure that you classify your data into persistent and not persistent. Storage could be also reattached to another pod if it is basically persistent, so you can go into that direction as well. Since we do not have so much time, we need to start going over another module right away. And this is going to be the last module for this cram session. Then we're going to have approximately 20 minutes to discuss all of the questions that you have about the course. So we'll be available here for you to answer all of your questions. So now we'll talk about the administration of the monitoring in the Azure, which is also essential for your service. So you want to make sure that all your services are up and running. For that, we have the Azure Monitor, Azure Alerts, and the Log Analytics workspace, and we're now going to discover each of them. So, first, configuration of the Azure Monitor. So, what is the Azure Monitor? It's basically a core component for monitoring all of the services in the Azure. So, it can also monitor your on-premises, which is quite interesting. So Azure Monitor has also multiple components to it, and we're going to see them just in a bit. What it does, it collects metrics, activity logs, and diagnostic logs, and you can use it also for time-critical alerts and the notifications. So let's see now how the Azure Monitor works. On the left, we have the sources of the data. So your operating system can generate some data, your application, your Azure resources, tenant, and subscription. And then in the Azure Monitor world, it collects two types of data. It collects metrics and the logs. And we're going to explain in the next slide what are these two types of the data. So once you ingest the data into the Azure Monitor, so for metrics, they're collected by default from all your Azure resources. And the logs you need to send, you need to configure basically the shipping of the logs to the Log Analytics workspace. Once the data is collected, you can then use it to do different things, such as to visualize it using the dashboards and Power BI, respond to it using the alerts or auto-scaling, analyze it using the Log Analytics, and so on. So now let's explain what are these two different data types. So first we have metrics. Metrics are numerical values that describe the state of the system at a point in time. So we can take into consideration, for example, the CPU utilization on some of the virtual machines. So for example, CPU threshold or the utilization can describe how utilized was the CPU at your operating system. And because metrics are so lightweight, they can show this precisely in the metrics and the graphs. Then we have logs, which contain different kinds of data organized into different sets of properties, basically, in the data sets. And logs, as I mentioned, they need to be shipped to the log analytics workspace in order to be analyzed. There are different data types, obviously. So there is application monitoring data, which represents performance and functionality of your code. Guest OS monitoring, which is the monitoring of any guest OS in Azure or on-prem. Azure resource monitoring, so monitoring of your Azure resources. If you take VM into consideration, you will have utilization of the CPU, of the RAM, some network related metrics, and so on. And then we have subscription monitoring and the tenant monitoring, which are basically the operations of your subscription and the tenant. One of the logs that stands out is the activity log, and activity logs describe who did what at what point in time in your Azure environment. So for example, if I go now in my Azure environment and I reboot the virtual machine, I can see in the